Okay, geometry, this is going to be kind of a short video, I think. We only have one proof and then a couple things to write down. But this is the last little bit of the 2-6 notes. We stopped after the vertical angles theorem. So we wrote this guy down and we said for vertical angles like 2 and 4, the ones that are on top of each other, or the ones that are directly opposite each other like 1 and 3, vertical angles theorem said that those guys are going to be exactly the same measure. And you can kind of see that from how we have it labeled here, that those are going to be exactly the same measure. So you can almost guarantee that in example 4 in this proof that we have going on right here, we're probably going to use that vertical angles theorem at some point. Okay, so we're going to jump right into this proof, example 4, and then we'll go to the backside and write those things down. Okay, so prove that if DB bisects ADC. Okay, let's look at our diagram over here. DB bisects ADC. DB is this guy right here, and we want it to bisect ADC. Okay, so just kind of in our mind, if this guy is bisecting, like what does it mean to bisect? Bisect. If something bisects it, it splits it into 2 pieces, but those 2 pieces will be exactly the same. So this guy and this guy will be the same as each other. Right here, these 2 angles will be exactly the same measure. All right. So we're trying to show that if this guy bisects this one, then angle 2 and angle 3 will be the same. Right? 2 and 3, this angle will be the same as this one. Well, what the heck? Those guys aren't even like close to each other, right? How do we show that those are the same? Okay, well, we know that we're going to end up using the vertical angles theorem somewhere in this proof. Okay, and the only 2 vertical angles that I see are angle 1 and angle 3. Those guys are vertical from one another. Okay, so kind of mapping this out in my mind, I know that angle 1 has to be the same as angle 3 because they're vertical angles, right? I'm just going to do my little scratch work off to the side. I know that angle 1 and angle 3 have to be the same because they're vertical angles, okay? Well, but we just said that angle 1 has to be the same as angle 2 because of that bisector thing, right? Bisector. So if 1 and 3 are the same, and 1 and 2 are the same, is there a way of connecting 2 and 3 to be the same? I don't know. We're going to map it out here. So we have to decide what we are given. The only thing that we are given is that DB is bisects angle ADC. That's what we are given, and we are trying to prove that angle 2 is congruent to angle 3. Okay, so we're going to start with our given information, and then we're going to draw information from that. Okay. All right. There we go. We're a little less fuzzy. So DB is that line segment. He's going to bisect angle ADC. So we know that that is given. All right, so from our diagram, if this guy is bisecting this angle right here, okay, we just kind of said that the thing that we can draw from that is that angle 1 has to be the same thing as angle 2, right? And how do we know that those 2 things are the same? Well, it's kind of just because those are things this guy is bisecting. That is called the definition of angle bisector. Okay, by definition of an angle bisector, if an angle bisects, if a segment bisects another angle, then it's going to split it into 2 equal pieces. Like angle 1 is going to be the same as angle 2. Okay, now where do we go from there? Well, let's jump over here to our scratch work. We said that angle 1 has to be the same thing as angle 3, right? And how do we know that that's true? Well, because of the vertical angles theorem. Up here at the top, vertical angles theorem right there. They are vertical angles from each other, so they have to be the same. Vertical angles theorem. Okay, now I'm trying to get to the point where 2 and 3 are the same. Okay, now let's decide. Can we jump straight to that? Can we jump straight to 2 and 3 being the same? If 1 is equal to 2 and 1 is equal to 3, can we say that 2 and 3 are the same? Yeah, you bet we can. Angle 2 has to be congruent to angle 3. Now, how do I know that I can say that? Okay, well, if you look at angle 1 is the same thing as angle 2, right? And if we have angle 1 written here, we can basically replace that angle 1 with angle 2. He can be slapped in there, right? So if angle 1 is angle 2 can be put in the place of any angle 1 that we see on this proof at all. So we have angle 2 is the same as angle 3, and we can do that because of substitution. Substitution will be used a lot in proofs. So the substitution property used a lot in proofs. Okay, now what? We're done. That was nice and easy. Okay, so drawing your conclusions to start with, kind of come up with like a thought process of how you're gonna map things out and how you can get from one to the other. Maybe even do some scratch work off to the side to help you get there. But as soon as you kind of see the big picture, then it's like just doing the logistics of things, like what do we name it? What do we call that reason? That type of thing. Okay. All right. Go to the back side. We have to talk about these. What are there? 5 of them. 5 of them. And we have to write them down on your purple sheet. Okay. You guys need to have your purple sheets in front of you. We just finished filling out the bottom side, like we were all the way down at the bottom when we stopped with this purple sheet. Okay. So flip this over to the back side. If you are like me, look at my back side. I am not going to write on that. So if yours is bleeding through, I have left with my sub some extra purple sheets. So go ahead and grab one from her. You might have to pause this video, go grab one from her. I left them there. If she hasn't already kind of flagged you down and said that she has those extra. But grab one of those from her, and you can write these 5 down, okay? So these 5 are kind of just some other theorems that just make kind of sense, I guess. They do not have names other than them being right angle theorems. They all have to do with 90-degree angles. So they don't have names, but they do have numbers. So we're going to call this one Theorem 2.9. Okay, Theorem 2.9. This is what he is. All right, it says perpendicular lines intersect to form 4 right angles. Okay, so I'm going to do perp lines form 4 right angles. Okay, that's my abbreviation for angles, right? And perpendicular, if you haven't already figured this out, the symbol for perpendicular is an upside down T, right? It's kind of like 2 lines that are coming together to form right 90-degree angles, okay? So if here's my perpendicular lines, right? Those are forming 90-degree angles. It's not going to just form one right here. All 4 of those are going to be 90s, right? Perpendicular lines are going to intersect and form 4 90-degree angles all the way around, okay? So that's just kind of basic, okay? And Theorem 210 is even worse than that. Theorem 210 says 10, all right angles are congruent. That's kind of silly. I'm just going to do like 90 degrees. If it's 90 degrees, it's equal 90 degrees. That's kind of silly. All right angles are the same. All right, 211. Theorem 2.11. Perpendicular lines form congruent adjacent angles. Okay, this one's kind of more complex. Perpendicular lines form congruent adjacent angles. Okay, so let's see what they mean by that. Here's my perpendicular lines. What does adjacent mean? Think about what adjacent means. I'm going to write in here right next to. Okay, so adjacent means right next to. So like this angle right here and this angle right here, those 2 are adjacent to each other. Adjacent. Adjacent, those 2. This one here and this one here. And those 2 are right next to each other. They are adjacent. Okay, are they congruent? Are they the same measure? You bet they are, because they're both 90s. Okay. Now, in addition to that, this guy and this guy are also adjacent. And this guy and this guy are also adjacent. You don't need to write all those things down, all those arrows down, because it's kind of mucking up the paper. But anyway, any 2 that are right next to each other are going to be adjacent angles, and they're all going to be 90s, so they're all going to be congruent. Okay. All right. Theorem 212. All right. I kind of went over this with my 6th period kids once. Not sure if we did 1st period or not, but if 2 angles are congruent and supplementary, then each angle is a right angle. Okay, so if I'm thinking about supplementary, they're kind of like together on a straight line, right? Two angles that are together on a straight line, but I know that this angle has to match up with this one, right? So not only do they have to add up to be 180 degrees, but they both have to be the same, right? And the only way that they both can be the same is if they both are 90 degrees, right? That kind of just makes sense. So if congruent and supplementary, both angles equal 90 degrees, or both angles are right angles. If they're both the same measure, but they have to add up to be 180, there's no other choice that they are both 90 degrees, okay? And the last one, if two congruent angles form a linear pair, then they are right angles. So that's kind of saying the same thing. Theorem 213. If two congruent angles form linear pair, then both right angles. Okay, so maybe I should have drawn this picture a little bit different, because in order for them to be supplementary, they do not necessarily have to be touching, right? But for this proof right here, this theorem right here, they do both have to be touching. They both have to be a linear pair. They have to be on a straight line. Okay, so this first one could be any two angles that are supplementary. They have to be 90 degrees if they're equal. This one, if they're a linear pair and they're the same, then they have to be 90 degrees. Okay, so these two proofs, or these two theorems right here, are just covering both of your bases. If they're touching on a straight line, great. If they're not touching on a straight line, but they still add up to be 180 degrees, then that's covered under theorem 212 as well. Okay. All right. So just those. Your homework sheet that we did on Friday for 2-6, just add the proofs down at the bottom. I think those are the ones that have blanks on them as well. But make sure that you are using this purple sheet as you go through those proofs, and just fill in the blanks as to what the reasons are, what they're doing, that type of thing. Okay. If you are missing that homework sheet, I left some extras. Yeah, so you should be good to go.